All right, this video is the last video of a series of 4 videos talking about transformations of functions that I've made here. Since we've already talked about the basics of sort of how this works, these functions are going to be a little bit more complex, but again, I'm going to move through the basic steps a little bit faster. The biggest thing we want to keep in mind are the order of operations. So you'll notice m of x up here, up at the upper left, is negative 1/4 x cubed. The most important thing I notice in there, or the parent function, is going to be that x cubed. So already I'm thinking it's going to be one of those S curves. Again, I'm going to just put some basic points down. 1 cubed is 1, 2 cubed would be 8. Again, negative 1 and negative 8 down here. And again, we're going to get sort of that basic S curve for a function. Again, that's our parent function. The big difference, and if you plot it on your calculator, that we're going to have is that negative 1/4. Now, technically, there are 2 things happening right there. Number 1 is the 1/4. It's going to be a vertical shrink. Again, I know it's vertical because it's happening after the x cubed, and it's going to shrink because, again, vertically things happen as you would think. 1/4 of something is going to get smaller. So I can say vertical shrink by 1/4. So already I'm thinking my points are going to be a quarter of the way back down toward the x-axis. 1 would only be a quarter, and 8, again, would only be down at 2. However, don't forget about that negative. A negative on the outside is also a vertical reflection. So we're going to vertically reflect, and if you want to say over the x-axis, again, to reflect vertically, we have to move from top to bottom, or bottom to top. Again, we're going to reflect over the x-axis, right? Or we're going to have those negative are going to affect the y values. Y values would change positive to negative over the x-axis. So now I'm going to take that 1/4, I'm going to move it down to negative 1/4, or that 2 is going to become negative 2. And basically what happens is my S curve is going to get a little bit sort of vertically shrunk. It's going to look wider or shorter, but it's also going to be negatively down to the bottom. And in fact, if we think about it, 3 cubed would have been 27, but divided by 4 is just short of 7. So actually, I'm going to have a point down here. I'm going to give myself something else to aim for, just a little bit short of 7 there. So notice we can fit another point because we've gotten just a little bit of a wider graph. In the same way, we're going to travel upwards in the same idea. So again, I'm going to have a point here, have a point here, and again, just short of 7 up this way. So we're going to be able to kind of draw that graph, right, up this direction. It's vertically shrunk by a quarter and vertically reflected over that x-axis. In that same way, we can write out the function notation, right, for our graph. Basic idea is, again, m of x is going to be equal to, well, anywhere there was that x cubed, that just becomes f of x. And the basic idea was we took that times a negative 1/4 because it's all outside the function. That's all we have to do to write it. Let's go a little bit quicker with the one over here at the right. Again, your parent function is going to be an absolute value of x. And if we wanted to, we could actually immediately write out the fact that n of x is really a negative on the outside of that absolute value, so a negative outside of f of x. Inside, it's an x plus 2, right? So that's going to take us left 2. And on the outside, again, notice I closed the parenthesis, a minus 3. So again, let's walk our way through those functions. First thing happening is actually happening inside. So we're going to talk about the horizontal change first. Horizontally, we're adding 2, so technically we're going to go left, horizontal shift, left 2. Then we're going to multiply, so that's where the negative comes into play. So this is going to be a vertical reflection again, much like the first example. And then finally, we're going to subtract 3, but again, outside, so vertically shift down 3 units. So again, where we would normally have a square root, or sorry, an absolute value, just a simple V shape, right, traveling up this direction and traveling directly to the origin in here. Now what we're going to have is we're going to shift to the left 2 units. We're going to reflect. Well, notice the vertex isn't going to go anywhere in that case, but then we're going to go down 3 units. And because we never multiplied by anything, we're still sort of a slope of 1, if you will, to the right, or -1 to the left. Basically going downwards, the same thing's going to happen. We're left 2, down 3, but again, going to reflect this thing vertically. See how accurately I can hit those points. That looks a little better down this direction. And again, you could check other points as well. May as well look at one here. Let's talk about, how about 5, 5? Again, if I went left 2 units and then down 3 units, but then I reflected, right, vertically. Oops, I went in the wrong order though, didn't I? No wonder that wasn't going to work. We're not up here, are we? This is where that order does matter. See how I did that there? We need to go left 2 units, but then we need to reflect, right, down to -5, then go down 1, 2, 3 units. And notice we end up right on top of our blue line. Again, if you want to try a few other points, pause the video now and you can kind of picture. Make sure you follow that order though. The order in which you transform their function does matter. Inside the grouping symbols, right, PEMDAS, remember the old parentheses, inside our grouping symbols, then comes multiplying, then finally comes subtraction on the outside. All right, one last one for you, and just a hint for you. When they get tricky like this, if there's multiple things going on the inside, I highly recommend some factoring. U of x would actually be much easier to picture if we took that negative out of our function there, right? Out of our function. So that when we plug points in, right, like let's say we just went to plug in a number like 2, well, -2 minus 2 is going to be -4. Well, that actually won't work too well for us, will it? But notice we would have kind of known that down here at the bottom. So how about we plug a number in like maybe -6, right? If we plug -6 in here, -6 plus 2 is -4. Double that negative makes +4, and the square root would give us 2. Okay? So notice it's just helpful to have -6, 1, 2, 3, 4, 5, 6, +2 up here. Well, let's kind of picture what's happening here, right? -6 in our new function, right, basically gave us what +4 would have otherwise given us, right? +4. So if we think about that inside being backwards, so I can kind of think backwards order of operations as well. What if I reflected first, right? +4, right? The square root of 4 would have been 2, so here's where I would have been if just the square root was happening. But again, I'm going to reflect over to -4, and then +2, I'm going to move left 2. So when we list off our order of transformations here, right, again, our basic parent function is f of x equals the square root of x. But when I list these off, what I want to list off is I'm going to horizontally reflect, and I'm going to horizontally shift left. Remember, addition inside goes backwards 2 units. So it used to be, right, a square root function going out this way. Well, I'm going to horizontally shift it left 2 units. Right, my origin really wouldn't have mattered as far as the reflection goes. Now it's over here. And what's going to happen is we're going to end up going up to the left. I'm both horizontally reflected and then shifted over 2 units. Again, the idea is we've taken u of x, right, equal to f of a negative x plus 2, and I got to do both the operations backwards, right? +2 took us left, but also do the order of operations backwards. I'm actually going to start with the multiplying and then shift left 2 units. Again, I hope that helps. Again, they get a little tricky when they're inside there. Always a great idea to double check yourself, verify that on your calculator. You should have access to your calculator pretty much on all tests and quizzes, I would imagine. But again, verify that just so that we know we're ending up in the correct place. If you have any questions, talk to your teacher. Otherwise, have a great day.